Good afternoon, everyone. Welcome to today's live session. As usual, I will start by walking through some questions that I have here, and then I'll answer any questions that you may have. And as we go through the topics, feel free to stop me along the way or to post your questions along the way so that those questions can get answered for you. In today's live stream, I have some questions for SAT and ACT students as well. I'll try to show you how to go through those type of problems. Okay, I'll get started now, and when students come in, or parents come in, they can ask their questions. So our first question here has to do with fractions. We're going to add an improper fraction and a proper fraction together. The question here is 7 over 5 plus 8 over 15. When you're adding fractions or subtracting fractions, the most important thing to remember is to make sure that your denominators are the same. So here we have a denominator of 5 and a denominator of 15. Because we can see that 15 is a multiple of 5, that means that our least common denominator is going to be 15. So the first step we're going to take is to convert both fractions to equivalent fractions with a denominator of 15. So we have 7 over 5. We want a denominator of 15. So what do I need to multiply 5 by to get to 15? I'm going to multiply 5 by 3. So therefore, I'm also going to multiply 7 by 3. So that's going to give me 21 over 15. And then I have 8 over 15. Because we already have the denominator at 15, we don't have to do anything to that fraction. So now I have 21 over 15 plus 8 over 15. So now that we have the same denominators, we can add the numerators. So our denominator is 15. 21 plus 8, that's going to give us, let's write this here, 21 plus 8, which is going to give us 29 over 15. Now you can leave your answer in this form. This will be acceptable for some teachers, but let's go ahead and convert this to a mixed number. 29 divided by 15. How many groups of 15 do we have in 29? Let's go and look for what 15 multiplied by 2 is going to give us. We have 5 multiplied by 2 is 10. You write 0, you bring 1 up here. 1 multiplied by 2, we have 2 plus 1, 3. So there's only one group of 15 in 29. So that is 1. 15 multiplied by 1 is 15. Let's go ahead and subtract. It's going to be 4 here, 1. So this is going to give us one group of 15 in 29 with a remainder of 14 out of 15. So that is the solution to this problem. The next one, is there no question so far? So now let's go ahead to the next problem. We're going to arrange these fractions in increasing order. So that means we want to arrange from the smallest to the largest. The first thing we're going to do here is to find a way to make all the fractions have the same denominators so you can compare the numerators. Now what we're going to do is to find the least common multiple of 6, 3, 10, 8, and 15. So 6 is going to be 2 multiplied by 3. Remember that in our previous lesson I had said that it's easier to use prime factors here. So I'm going to use 2 multiplied by 3. 3 is going to be 3 multiplied by 1, but you don't have to use the 1 here because 1 isn't a prime number. Then 10 is 2 multiplied by 5. 8 is 2 multiplied by 2 multiplied by 2. If you have any questions on how we get to this, let me know. And then 15 is 3 multiplied by 5. So our least common denominator is going to be, so we're going to account for the 2, we're going to account for the 3 and the 5. So we have 2 multiplied by 2 multiplied by 2. So that's the largest frequency of 2. What about 3? 3 multiplied by 1, there's only one of them, and then there's only one 5. So now we have LCD is 2 multiplied by 2 multiplied by 2, that's 8 multiplied by 3 multiplied by 5. So this is 24 multiplied by 5, and that is going to give you 120. That's going to be 120. So that's one way to go about it. If you don't want to use exponents, this is the way to go about it. The other way to do it is to list all the factors, and by the time you get to 120, you would have listed 40 factors of 3, 40 multiples rather, list all the multiples. You would have listed 40 multiples of 3, 20 multiples of 6, 10 multiples of 12 multiples of 10, and 15 multiples of 8. So you get the point. So this is going to take you a shorter time to do it. So what we're going to do now is we're going to rewrite each of these fractions so that they have a denominator of 120. So we have 5 over 6. 5 over 6. We're going to change this so that we have a denominator of 120. So I'm going to multiply 6 by 20. And then I multiply 5 by 20 as well. So this is going to give me 100 over 120. The next one is 2/3. So 2 over 3. I need to have 120 as our denominator. So I'm going to multiply 3 by 40. And then also multiply 2 by 40. This is going to give me 80 over 120. 3 over 10. I'm going to multiply 10 by 12. And then also multiply 3 by 12. And that's going to give me 36 over 120. 7 over 8. I'm going to multiply by 15, the denominator, to get to 120. And then multiply 7 also by 15. And I have 105 over 120. And then 11 over 15, I'm going to multiply 15 by 8. And then also 11 by 8. And this will give me 88 over 120. So let's go ahead and rewrite all of these fractions in such a way that we're going to replace all these fractions with the new fractions we created. So 5 over 6 is 100 over 120. 2 over 3 is 80 over 120. 3 over 10 is 36 over 120. 7 over 8 is 105 over 120. And then 11 over 15 is 88 over 120. So now what we need to do is we're saying that we want to arrange them from the smallest all the way to the largest. So what we're going to do is, now that we have all the denominators the same, we're going to focus on the numerator. So let's start from the smallest numerator. I'm just going to write number 1 through 5 on them. So this is the smallest, 36. The next smallest one is 80. The next one after that is 88. The next one after that is 100. And then the largest one is 105. So now we're going to replace this with the original fraction. So we have the smallest one is 36 over 120. We can see that that is 3 over 10. The next one is 80 over 120. We see that that is 2/3. The next one is 88 over 120. That is going to give us 11 over 15. The one after that is 100 over 120. And that is going to give us 5 over 6. And then finally, you have 105 over 120, and that is 7 over 8. So this is the fraction approach. The other way you could do this is to convert every single one of them to decimals. That may take you longer than doing it this way, so I tend to use the fraction approach to solve this type of questions. Okay, any questions on this? If you have any questions, remember, send them through the chat and we'll be glad to address them for you. The next one is, what is the value of 24.96 divided by 1.6? This is dividing decimals. So we're dividing decimals here. So let's go ahead and I'll show you a method that I like to use. It's very easy to do. So let's go ahead and do this. We have 24.96 divided by 1.6. It's actually difficult to divide when you have a decimal in as your divisor, which is the number right here. So what I like to do is I like to move the decimal point here until it's at the end of the number. So what I'm going to do here is I'm going to move the decimal right here. So I am going to have 16 on this side. And then because I moved the decimal 1 unit to the right, I'm also going to move it 1 unit to the right over here. So now our division is going to look like this. 249.6 divided by 16. So we'll start off with our division now. 2 divided by 16, we can't do that. What about 24? How many groups of 16 in 24? I'm going to ignore the decimal while I'm doing the division, and I'll show you what to do with it afterward. So 24 divided by 16, I have only one group of 16 in 24. 1 multiplied by 16, I have 16. I'm now going to subtract. 14 minus 6, I'm going to get 8. I bring down the 9. 89 divided by 16. How many groups of 16 do you have in 89? I'm just going to pick, because it's 8, I'm going to pick 5. So 16 multiplied by 5 is going to give me 6 multiplied by 5 is 30. I write a 0 here and I bring up a 3. 1 multiplied by 5, I have 5 plus 3, I have 8. So we have 5 groups of 16 in 89. 5 multiplied by 16, the answer is 80. And we subtract, we have a remainder of 9. And then now we bring down a 6. So 96 divided by 16. So this is going to give me, let's go 6. Let's multiply 16 by 6. 16 multiplied by 6. 6 multiplied by 6, we have 36. We write 6, bring up a 3. 1 multiplied by 6, 6 plus 3, we have 9. So 16 multiplied by 6, we have 96. So we subtract and we're left with a remainder of 0. But take note of this. We have just one decimal here. There's only one number after the decimal in our original number that we're working with right now. So in our answer, we're going to put one number after the decimal as well. So you're going to have 24.96 divided by 1.6 is going to give you 15.6. Just as a bonus here, let's go ahead and see if we can go the reverse. So I'm going to multiply 15 by 15.6. 15.6 multiplied by 1.6. So here I'm going to also ignore the decimals while I'm multiplying. 6 multiplied by 6, I have 36. So I'm going to write 6 here and bring a 3 up here. 5 multiplied by 6, 30 plus 3, 33. So I'm going to write 3 over here and bring 3 up here. 1 multiplied by 6 is 6 plus 3, that is 9. So now we go over to the tens place, so we're going to put a 0 in the ones place. 6 multiplied by 1, we have 6. 5 multiplied by 1, we have 5. And 1 multiplied by 1, we have 1. We're going to place a 0 up here, just so we have 4 digits above and below. So now we can add all the numbers together. 6 plus 0, we have 6. 3 plus 6, we have 9. 9 plus 5, we have 14. So we write 4 here and bring 1 up here. 1 plus 0 plus 1, that's going to give us 2. Now with multiplication, so we have one number after the decimal here, one after the decimal. We're going to count how many numbers all together after the decimal. We have 2 numbers after the decimal, so we're going to go 1, 2. So now we get back to where we started. Let's see what kind of questions do we have. My second grader is asking, how do you add 2-digit fractions in second grade? Okay, I can look at that. I'll look at that in a few minutes. Give me some time. Okay, so next one is, let's convert 36% to a fraction. 36% simply means that you have 36 with a denominator of 100. That's what the percent means. Okay, using the increment strategy. Okay, we can look at that. I'll have to say, I know that's probably Common Core. Common Core, so I'll have to look at that for you. Give me a second. So 36 divided by 100. So these two numbers are even numbers, so we're going to divide them by 2. So 36 divided by 2. We're going to have, let's go ahead, because we have younger students here, let's go ahead and go through the process. 36 divided by 2. 3 divided by 2. So how many groups of 2 can you find in 3? There's going to be 1. 1 multiplied by 2, we have 2. We subtract, and we have 1. We bring down the 6. Now, how many groups of 2 can you find in 16? There'll be 8 of them. 8 multiplied by 2. This is 16. We subtract here, and we have 0. So 36 divided by 2 is 18. 100 divided by 2. So this is going to give us 50. Now, there are still 2 even numbers, so we can divide by 2 again. 18 divided by 2, we have 9. And then 50 divided by 2. 50 divided by 2. How many groups of 2 in 5? We have 2 of those. 2 multiplied by 2, we have 4. We subtract. 5 minus 4, 1. Then we bring down the 0. 10 divided by 2, we have 5. 5 multiplied by 2, we have 10. So this is 25. We have no more common factors because the factors of these are 1, 3, and 9. The factor of these are 1, 5, 25. So you can see that there's no common factor. No common prime factor. I mean, dividing by 1 doesn't make any difference because you end up with the same number. So because we have no common factors, then this is going to be our final answer. Now let's go ahead. There was a question about this. This was actually a question posed in yesterday's session. So I'm going to go ahead and spend some time walking through this. So we have x minus 6. I'm going to use the FOIL method. FOIL method. And the F here stands for the first terms in each of the binomial expressions. The O stands for the terms that are outer terms. So outer on the one to the leftmost term and the rightmost term. The inner are the ones that are close together. And then the last are going to be the last terms for each binomial expression. So let's go ahead and walk through this. So we have our first terms are x and x. So this is first right here. X and x are our first terms. So x multiplied by x. Now the outer terms are going to be right here is x and negative 2. This is positive x and then negative 2. And then the inner terms are the ones that are quite right next together. So these are the inner terms. Then this is minus 6 multiplied by x. And then the last terms are these ones right here. So we now have minus 6 multiplied by minus 2 or negative 2. So let's go ahead and simplify. X multiplied by x, that is x squared. X multiplied by negative 2 is negative 2x. X multiplied by negative 6, that's going to give you negative 6x. And negative 6 multiplied by negative 2 is going to give you positive 12. So now we have x squared, negative 2x minus 6x is going to give us negative 8x. And then we have plus 12. So that is this. That is the way you simplify or you distribute this. You multiply two binomial expressions together. So this is one method. There is another method. Let me show you another method. See which one you prefer. One thing I believe about math is there are many ways to get to the answer. So just find one that is comfortable for you. So let me show you another method. So we have x minus 6, x minus 2. So what I'm going to do now is I'm going to keep one of these. We're going to use distribution. I'm going to make one of these consistent. So I'm going to just make x minus 2 consistent. And I'm going to multiply each of the terms in here with the term that has an x on top of it. So what I'm saying here is I'm going to say x multiplied by x minus 2 minus 6 multiplied by x minus 2. So this is called the distribution method. And the other one I showed you earlier is the FOIL method. So now we're going to distribute these variables and the number into the parentheses. So x multiplied by x is going to give us x squared. X multiplied by negative 2 is minus 2x. Minus 6, negative 6 multiplied by x is negative 6x. And negative 6 multiplied by negative 2 is plus 12. So you can see that we get to exactly the same position. We get to the same result. So this is x squared. Negative 2x minus 6x is negative 8x. And then plus 12. So now we have f of x equal to, we have this fraction, it's called a rational fraction. So we have x squared minus 6x plus 3. What is f of negative 2? So this is a topic you'll see in Algebra 1, Algebra 2. It's also one that I actually got this from an SAT exam question. So I'm going to show you how to go about this. The first thing you want to do when you have a function like this is, I like to say, how would you rewrite this function in words? So what I'm going to do is, I'm going to say this is x. For every instance of x, I'm going to square it. I'm going to multiply it by negative 6. And I'm going to add 3 to the result. And then for the denominator here, for every instance of x, I'm just going to subtract 1 from it. So now what we're going to do is we're going to, everything in parentheses here, we're going to replace that with negative 2. So now we have f of negative 2. So inside the parentheses, I'm going to replace that with negative 2. I'm going to square it, minus 6. And then I'm going to replace that with negative 2 plus 3. And then I'm going to divide. So now I have my parentheses here. I'm going to replace that with negative 2 and then subtract 1. So now we can go ahead and simplify. Negative 2 squared is going to be negative 2 times negative 2, which is going to give you 4. Minus negative 6 multiplied by negative 2, that's going to be positive 12 plus 3 divided by negative 2 minus 1, negative 3. So this is going to give us 4 plus 12, 16 plus 3, 19 divided by negative 3, which is the same as negative 19 over 3. And the reason why this is with the rule of positive and negative numbers. When you have a positive number, when you have different signs in division, the answer is always going to be a negative value. So that's why you do this. I hope this is one of the questions about variables that you're asking. Otherwise, if you have a different set of questions or type of question, let me know and then we can go over it. So this is another SAT question. And this one is, we have this equation ax plus 3 squared equal to 36. A is a constant value. if x equal to -3 is one solution to the equation, what are the possible values of a? So the first thing we do here is we're going to substitute this into the equation, x equal to -3. So we're going to have -3a plus 3 squared equal to 36. Now, we want to make sure that we can get to the value in the parentheses. So what we're going to do here is we're going to find the square root of both sides. And here's a key point here. It's asking for possible values. So that means that they give me the permission to use positive or negative in front of the square root. Here's why we do that. If I have minus -a multiplied by -a, guess what I'm going to get? A squared. If I have positive a multiplied by positive a, I also get a squared. That is why when you have a square root, you have a possibility of a positive result or a negative result. We don't do that on the variable side. If you do it on the variable side, it's not going to get you anything. You're going to have to do your computation 4 times. But if you leave it on this one side, it's just going to be twice. And I'll show you the benefit of doing it just here. So when you take the square root here, we have -3a plus 3 equal to plus or minus. What is the square root of 36? That's going to give you 6. That simply means that 6 multiplied by itself gives you 36. Now we have two sets of answers. We're going to have -3a plus 3 equal to positive 6. We're also going to have -3a plus 3 equal to -6. So we're going to solve these two equations. And then we're going to let's start with this one. We're going to subtract 3 here, subtract 3. So -3a is equal to 3. So let's divide both sides by -3. And so a is equal to -1. Now let's go ahead and subtract 3 from both sides here. So -3a is equal to -9. Let's divide both sides by -3 to get the value of a. So a is equal to 3. So your two values of a are, a is going to be equal to -1 or 3. So that's what you will do. This is a sample SAT question, and this is how you want to deal with them when you see this type of questions. Now, there was a question yesterday about mean absolute deviation. This is very common in 7th and 8th grades. Some schools may introduce it in 6th grade, but on average, at least in the United States, it's 7th or 8th grade. For the 7th graders, it's going to be pre-AP. For the 8th graders, it's going to be academic. So the first thing, we're looking for the mean absolute deviation. I like to create a table for this. It makes it a lot easier to follow. So I'm going to say x, each of these values, I'm going to write them under x. Then I'm going to find the mean. I'm going to use mean here because you may not be familiar with the symbol used. The symbol used is usually this. And then we're going to find x minus mean. Then we find the absolute of x minus mean. And then we'll find the average of x minus mean absolute. So let me show you how to do that. Order of operations with variables. Okay, no problem. So let's look at the values of x. We have 3, 6, 6, 7, 8, 11, 15, and 16. So what we need to do first is find the mean of these numbers. So the mean simply means the average. So the average of these numbers is the sum of all the numbers divided by the count of the numbers. So let's go ahead and add these numbers together. 3 plus 6 plus 6 plus 7 plus 8 plus 11 plus 15 plus 16. And then we're going to count how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 numbers. So now let's go ahead and add the numbers together. 3 plus 6, that's going to give me 9. 9 plus 6 is going to give me 15. 15 plus 7 22. 22 plus 8, I have 30. 30 plus 11, I have 41. 41 plus 15, I have 56. 56 plus 16, I have 72. And so I have, my mean is going to be 72 divided by 8, which is equal to 9. So I'm just going to write 9 for all of these right here. 9. Okay, so now we're going to subtract x. We're going to have x minus the mean. So 3 minus 9 is going to give us negative 6 because the number here is larger. So you're going to have a negative number. 6 minus 9, so it's 9 minus 6, but the number here is larger, so it's negative 3. This is going to give us negative 3. 7 minus 9 is negative 2. 8 minus 9, negative 1. 11 minus 9 is 2. 15 minus 9 is 6. 16 minus 9 is 7. So now we want to find the absolute value for each of these numbers here. So the absolute simply means that you're going to, each of these numbers becomes positive. So negative 6 becomes positive 6. Negative 3 becomes positive 3. It also becomes positive 3 here. Negative 2 becomes positive 2. Negative 1 becomes positive 1. Then we have 2, 6, and 7. They stay positive. So when you have absolute, all the values between the absolute signs, which is these vertical bars, every number in here ends up becoming positive. So now we're going to find the mean of all of these values right here. From here all the way to here, we need to find the mean of those values. So mean absolute deviation is going to give us, let's put a dot here, 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7, and we have 8 numbers. So this is going to give us 6 plus 3, we have 9, 9 plus 3, we have 12, 12 plus 2, 14 plus 1, 15 plus 2, 17 plus 6, 23 plus 7, 30. So now we're left with 30 over 8. And then we can divide this. Here you can convert this to a decimal, or you can leave it as a fraction. It doesn't make a difference. So if I divide this by 2, I'm left with 15 over 4. And you can go ahead and convert it to a mixed number if you want. So 15 over 4. There are 3 groups of 4 in 15. 3 times 4, we have 12. We have a remainder of 3. So this is 3 3/4. And if you want to go to decimal, we can do this some other time. It's going to be 3.75. So that's mean absolute deviation. I hope this captures, this answers the question. This was a question from yesterday, and I wanted to make sure I had a good example that we could use to demonstrate the steps to get to the mean absolute deviation. Now we're going to look at some absolute values here. So we have negative 8 minus 15 plus 9 minus 19 between the absolute value signs. Now let's go ahead and simplify. What is 8 minus 15? There's something here that I know students struggle with a lot, which is positive and negative numbers, especially when it has to do with addition. So let me show you a trick that I typically use. So if I have signs that are opposite, if I have opposite signs, what I actually have to do is subtract. I'm going to subtract and then inherit the sign of the bigger number. So inherit sign of bigger number. And then if I have same signs, I just add and keep the sign. So I'll show you how to use that with this example here. 8 minus 15. So let's look at that. 8 minus 15. So there's a positive right here. If you don't have a negative sign, you can assume that it's positive number. So here we have different signs. So what we're saying here is that we're just going to take 15 and subtract 8 from it. So that's going to give us 7. Now, which of these numbers has what is the sign on the bigger number? 15 is larger than 8, so the sign on that is negative. And so we have negative 7 right here. And then same for 9 minus 19. So we subtract, so we have different signs here. And so what we're going to do is subtract 9 from 19. That's going to give us 10. And we're going to get this, we're going to inherit the sign that is in front of the larger number, which is negative. So this is going to give us plus negative 10. So notice here that there's a negative sign outside here. The negative sign doesn't affect what's inside the absolute value sign. So what you're going to do first is simplify what's in the absolute value, what is between the absolute value. So the absolute value of negative 7 is going to give me 7. I'm going to keep my negative sign out here. Plus, the absolute value of negative 10 is positive 10. So now we apply our rule again. The signs are different, so we're just going to subtract the number. So 10 minus 7 is 3. What is the sign on the larger number? This larger number is 10. The sign before it is positive. So our result is positive 3. And this is going to be this is the last set of questions before I'll get into the second grader and then the order of operations. Okay, we'll have to do that one tomorrow. Olutayo, we'll do that tomorrow because that is pre-calculus. So we'll get to that tomorrow. All right, so now this is final set of questions before I get into the other questions from other students. So now we have negative 5 plus 3 multiplied by x plus 7 equal to negative 14. So here we actually have to use PEMDAS. PEMDAS, GEMDAS, GEMA, PEMA, doesn't matter which one you use. There are lots of different ways, but the most important thing is parentheses or grouping, exponent, multiplication, division, addition, subtraction. And so we're going to start with our parentheses. So we have a parenthesis here. So let's go minus 5 plus. We're going to simplify the parentheses here. So it's going to be 3x plus 21 equal to negative 14. So now let's go ahead and simplify what's on the left hand side. So we have 3x plus 21 minus 5 is equal to negative 14. So 21 minus 5, because we have to group common terms together and try to fix them. We have common terms together. So 21 minus 5 is 16. So 3x plus 16 is equal to negative 14. So we need to isolate the x. The first thing we need to do is take out the 16. So we subtract 16 from both sides. And so 3x equal to, remember the rule, if the signs are the same, just add the numbers together. You get 30, and here we keep the sign. So now we have 3 multiplied by x. The opposite of that is to divide by 3. So we divide both sides by 3. So 3x is equal to 3x over 3 is negative 30 over 3. So therefore, this divides out. We have x equal to. Now, when you're dealing with multiplication and division, whenever the signs are the same, your answer is positive. Whenever the signs are different, your answer is negative. So 30 divided by 3 is 10. The signs are different, so we have a negative value. Now let's go ahead and answer some questions. So what is 341 minus 295 using the increment strategy? So 341 minus 295. So there are different ways to look at this one here. Some, and I need to know exactly some teachers use different terminology for this, so I will have to look at exactly what they're referring to. But what some teachers do here is you bring it up, you build up the place value. So we have 300, we have 40, and then we have 1. And then this one here is going to give us 200, we have 90, and then we have 5. So when you're doing a subtraction here, the first thing you want to do is let's look at the hundreds. So I'm going to subtract. Yeah, I'm dealing with the second and third grade questions. So we have 300 minus 200. That we have 0, 0. We have 100. Okay. So we have 100 left. So the 300 and 200 are gone. So we have 100 left. And because we're subtracting 295, we're going to now subtract 90. Sorry, that's 100, not 1,000. So because we have 100 left, we're going to subtract 90 next. Let's subtract 90 from that. 0 plus, minus 0, it's 0. And 10 minus 9 is 1. So now we've subtracted 90 from what's left over, which is 100. Now we're going to also subtract 5 from 10, and we're left with 5. So what we've done here is eliminated all the numbers here. So what do we have left? We have 5, we have 1, and then we have 40. And then we add all these numbers together, and we have 5 plus 1 is 6, 6 plus 0 is 6, and then you add 40 plus 1 plus 5, that's 46. Now that is the place value method of subtraction. Then you have the algorithm method of subtraction, which goes this way. 1 minus 5, you can't really do that. So you have to go over to 4 and borrow 1 from 4, and 4 is left with 3. And the one we borrow becomes 10. We add it to 1, it becomes 11. 11 minus 5, we have 6 on this side. Now we have 3 here. 3 minus 9, you can't take 9 from 3, so we're going to go over to its neighbor over here and take 1 from that neighbor, so the neighbor is left with 2. The 1 we take from that neighbor becomes 10, and we add it to 3, it becomes 13. 13 minus 9, we have 4. So those are the two different ways of going about subtraction. I hope this helps. Otherwise, I can come up with more examples for tomorrow's session that would go into this in detail. Can you explain order of operations with variables? All right, let me write something up. So order of operations with variables, we always start with PEMDAS. I always say P or G because different school districts use different terms for the first one. Some use P for parentheses, others use G for grouping. So it depends on what your school district prefers. So PEMDAS, so let's come up with some examples here. So let's say 3x minus 1 minus 4x. Well, let me just make one up here. Minus 4 squared plus 5x minus 3x plus 2 plus 6x. So I just made this up. I will try to find some other examples, something much more creative than what I've come up with in the like on the spot. So the first thing we're going to look at is PEMDAS. So we start with parentheses. We're going to distribute all our parentheses first. So we start you always start on the left hand side when you're dealing with order of operations. So we have 2 multiplied by 3x, we have 6x minus 2. And then I'm going to keep writing. And then so here you have parentheses, but this has an exponent. So I'm going to go ahead and deal with the parentheses. And then plus 5x. And then minus 4 multiplied by 3x is minus 12x. Minus 4 multiplied by 2 is negative 8. And then plus 6x. So now, when you have this kind of a situation, remember that this and this multiplication and division are on the same level. They have the same or they have the same priority, really. And then addition and subtraction also have the same priority. The only distinction here is that you start from the left. Whichever one comes first on the left hand side, you have to address them first. So let's go ahead and do this. So this is 6x minus 2 minus 16 is minus 18 plus, well, let's not put a plus yet because we have 5x minus 12x, we have negative 7x minus 8 and then plus 6x. So now we've simplified this. We can now go ahead and group common terms together. So that's going to give me 6x minus 7x plus 6x minus 18 minus 8. So 6x minus 7x is negative x plus 6x minus 18 minus 8 is minus 26. So this is going to give us 5x minus 26. So that's the simplified. How do you add two-digit fractions? Two-digit fractions. Okay, I'm surprised that's coming from a second grader. So let's go ahead and look at two-digit fractions. All right, let me make one up. Let's say 14 over 15 plus, let's say 10 over 3. And please clarify if this is not what you're looking for. I'm actually surprised the second grader is doing two-digit fractions. But I'm thinking you're probably looking at adding two-digit numbers together, but let's go ahead and do this. 14 over 15 plus 10 over 3. So we want to first come up with our least common denominator. I'm just looking at this right here. You should have 15 will be your least common denominator. So we have 14 over 15. We already have that with 15 as the least common denominator, so I don't have to do anything with this fraction. Then 10 over 3, we want to make sure that we get to 15 for the denominator. So that's going to give me 3 multiplied by 5. And whatever I do on the denominator, I must do on the numerator. So this is going to give me 50 over 15. So now let's go ahead and add them. 14 over 15 plus 50 over 15. So now, when you have the same denominators, you can add your numerators. So now we have 14 and 50. Let's add them together. 4 plus 0, we have 4. 1 plus 5, we have 6. So this is going to give us 64 over 15. And so this is really all you do when you're adding fractions. It doesn't matter how many digits the fractions are. The first thing you want to do is to find, let me write steps here. The first thing you want to do is find LCM. The second thing you want to do is create equivalent fractions with LCM. And then the third thing you want to do is add numerators. And then that should give you all that you need whenever you're trying to add fractions. Are there any other questions? Let me see. So the one on, I think there was a question on hyperbola. I will deal with that tomorrow. I don't think I can see any other questions. Does anyone have any questions you'd like me to address before we call it a session? Okay. I don't think I can see any other questions, so thank you for joining. Please invite as many friends of yours as you can that could benefit from this, especially as most of us are locked indoors. You know, we can't really go to school, and some of us are having distance learning. And for some of the students, I know that math without getting additional help could be challenging. So feel free to invite as many friends as you can, and also send some questions to us so that when this session is happening, we can address the questions that you have. If it's a topic you're learning in school and maybe through distance learning or all the other resources you haven't found enough assistance, be sure to let us know, and we will make sure that we can address those questions for you. Thank you for joining. I really appreciate your time, and thank you parents for allowing your children to join as well. And we'll see you tomorrow. Thank you. You're welcome. Okay, bye for now.